Welcome to Ask and Learn.
Okay, so here we're given an is equal to 5 times an minus 1 minus 6 times an minus 2 plus 2 to the power of n plus 3 times n. So first we want the roots characteristic equation. And so to do that, we're going to substitute where an is equal to r squared. An minus 1 will be equal to r. And an minus 2 is equal to 1. And all other functions of n will be equal to 0. So that transforms an then to r squared is equal to 5r minus 6. Okay, and if we subtract 5r and add 6 to both sides, and then factor, we get r minus 2 times r minus 3 is equal to 0. So r is equal to 2 and 3. So this means that our homogeneous portion of our solution, so put a little h for homogeneous, is going to be equal to some constant alpha 1 times 2 to the power of n plus alpha 2, another constant, times 3 to the power of n, which is each of our roots raised to the power of n. So we're just going to have this in our pocket for when we're ready for it and figure out the particular solution component. So the particular solution, we have f of n being equal to 2n plus 3 times n. So those were the components we said equal to 0 previously. And this is equal to 2 to the power of n plus 3 times n times 1 to the power of n. Okay, so 2 is a root of our characteristic equation with multiplicity 1, and 1 is not a root. So we're looking for a particular solution, going to be in the form of q times n times 2 to the power of n plus p1 times n plus p naught. So the thing is, this particular solution needs to satisfy our recurrence relation, right? So what we're going to do then is put it into our recurrence relation. So the recurrence relation being an equals 5an minus 1 minus 6 times an minus 2 plus 2 to the power of n plus 3 times n. And so when we put our particular solution in, we get q times n times 2 to the power of n plus p1 times n plus p naught is equal to 5 times q times n minus 1 times 2 to the power of n minus 1 plus 5 times p1 times n minus 1 plus 5 times P naught minus 6 times Q times n minus 2 to the power of 2 to the n minus 2 minus 6 times P1 times n minus 2 minus 6 times P naught plus 2 to the power of n plus 3 times n. Okay, so we're going to do a bit of simplifying here. And this is going to be equivalent to 4 times Q times n times 2 to the n minus 2 plus P1n plus P naught being equal to 10 times Q times n minus 1 times 2 to the n minus 2 plus 5 P1 n minus 1 plus 5 times P naught minus 6 times Q times n minus 2 times 2 to the n minus 2 minus 6 P1 times n minus 2 minus 6 times P naught plus 4 times 2 to the n minus 2 plus 3n. So the terms that were rewritten here were the first one on the left-hand side, the first one on the right-hand side, and the second to last, right? We really just pulled some of the 2's out of there. And in this form, it's a little bit easier to start subtracting the elements on the left from the ones on the right. Okay, once we do that, what we end up with is 0 is equal to negative 2q plus 4 times 2 to the n minus 2 plus negative 2 times P1 plus 3 times n plus 7 times P1 minus 2 times P naught. Okay, well, so these coefficients all have to be 0, right? The things that are in the brackets. So that means that 0 is equal to negative 2q plus 4. 0 is equal to negative 2p1 plus 3. And 0 is equal to 7p1 minus 2p0. Okay, so from this first equation, we can rewrite that as 4 is equal to negative 2q, which implies that q is equal to negative 2. Okay, we can do the same thing with the second one, where we'll rewrite this as 3 is equal to negative 2 times P1, which means that P1 is equal to that'd be -3. So we get 3/2 for P1. And then this last one requires us to put our value for P1 in here. So we get 2 times P0 is equal to 21/2. And then we just have to divide by 2, right? So we get that P0 is equal to 21/4. Okay, so now that we know these, we can construct our particular solution. So the particular solution, which was going to be q times n times 2 to the power of n plus p1 times n plus p0, then becomes -n 2 to the n plus 1 plus 3/2 n plus 21/4. Okay, and so then we just have to combine the homogeneous and particular solutions. So the final solution, an, is equal to alpha1 times 2 to the power of n plus alpha2, and of course you could put whatever you want there for the constants, times 3 to the n, minus n times 2 to the power of n plus 1 plus 3/2 n plus 21/4. And then that's going to be the entire solution.